Hello and good afternoon friends, welcome once again to the CEC-UGC live lecture. Dear friends, as you know that through these lectures we try to cater your needs of getting a higher education, of getting a maximum knowledge. Dear friends, in this session today we are going to talk on antioxidant chemistry. It is the area where major researches are carried out, and you too can think of doing research on this particular area. But what basically antioxidant chemistry is? For this, today we have with us in our studios Dr. Amit Kumar. Dr. Amit is Senior Assistant Professor in Department of Chemistry, Dayal Singh College, University of Delhi. Previously also, Dr. Amit has delivered a lecture on chemical thermodynamics, and we would be carrying more sessions on chemical thermodynamics. But today we have specifically chosen this topic only for you, so that you can think beyond till a point where you have not thought before. So, dear friends, let's once again welcome our guest, Dr. Amit Kumar, and let's discuss about the antioxidant chemistry. Hello sir, welcome to the EduSet lecture, and I hope that all the students who might be watching us right now, or all those who want to go for the research work or are keenly interested in research, this session would of course going to be benefit them. So, over to you sir.
Thank you very much for your kind words of introduction, and first of all I wish very good afternoon to all my listeners. Well friends, today we are going to discuss about antioxidant chemistry. Basically antioxidant chemistry, here we are not going to talk about much of a research, but actually there are questions in undergraduate students' mind that they are pursuing the chemistry. This has just been, they treat it as it is abstract knowledge, and they feel as if what to do, how to make a career in research, and what actually the research is. So today, by virtue of an introduction to this brief area, that is antioxidant chemistry, I would like to just introduce just one area and would like to convey that how career can be made in research and what research is actually all about. So although we are not going to discuss much about research topics, we are just giving an introduction to this field called antioxidant chemistry. Well, antioxidants, we need to understand what actually the antioxidants are, because it is the chemistry of molecules which act as antioxidants. So that is why they are being called antioxidant. The chemistry of these molecules has been called antioxidant chemistry. So antioxidants are basically been discussed in two particular areas, one in relation to biological systems and other in relation to food systems. So in a biological system, an antioxidant is actually defined as a substance that when present at low concentration compared to an oxidizable substrate would significantly delay or prevent oxidation of that substrate. Well, what actually is that oxidizable substrate? These are biomolecules of importance, that is lipids, proteins and the DNA. We all know that DNA is been the storehouse of information, and actually it is the DNA which guides the growth of an organism, and proteins are basically built up of amino acids which are the building blocks of an organism. So therefore these are important biomolecules, lipids too. So therefore the protection to these biomolecules is important, because they are susceptible to oxidizing species, and they are susceptible to therefore participation in oxidation processes. So this is one area where antioxidants comes into play. The another area lies in food sector. What is that actually? You must have you must have taken some packaged food sometime in your lifespan. In a packaged food, there is information that it is written that this contains so and so, it is made of so and so substances. Alongside, it is also written that there are class 2 preservatives are being added, or some preservatives are being added, or some packaged food also provides information on some codes of the compounds actually which are being added as preservative. So food supply and regulatory bodies actually consider these antioxidants as food additives, and they define them as substances that are used to preserve food by retarding deterioration of food and rancidity, that is the foul smell or decoloration, that these are all resulting from the oxidation of food substances. So, antioxidants, according to regulatory food supply bodies, they consider them as a class of preservative. Apart from this class, there are antimicrobial preservatives also. Well, so therefore, by this little brief discussion, we one thing is clear, that the antioxidant chemistry is applicable, or antioxidant science is applicable in two different areas. One is the food sector and the other is the health sector. And in food sector, actually the study of antioxidants is done for better food quality maintenance, for better understanding of how and which antioxidants we can try to preserve our food. Whereas in the health sector, our focus of study of antioxidant lies mainly on studying the relation to oxidative stress related disorders which comes up in an organism. Now, therefore, as I have now introduced a new term called oxidative stress, so therefore, it is important to understand what is actually an oxidative stress. So, there are two important points, one the auto-oxidation and the oxidative stress we need to define. So, now it is clear that there is need of antioxidants for preservation of food in food sector and to counter oxidative stress in health sector. Let us now understand what is auto-oxidation and oxidative stress respectively. So, first we start with auto-oxidation. Well, auto-oxidation is the oxidative deterioration of unsaturated fatty acids via an autocatalytic process consisting of a free radical chain mechanism. You must have understood in your chemical kinetics chapter that there are a number of chain reaction which takes place. So, here auto-oxidation is being explained using the free radical chain mechanism. The chain includes, we all know that there is an initiation step, there is a propagation step, following which there is a chain termination step. And once started, these steps could be cyclical in nature. That is why this process is being called auto-oxidation. To understand this, we must understand that in food tissues there are lipids, and the fatty acids of lipids in food tissues maybe are unsaturated or saturated in nature, and or maybe they are part of a triglyceride or a phospholipid fraction. There are some electron deficient sites in fatty acids. These electron deficient sites are, for example, oxygen atom of a carbonyl group or a carbon-carbon double bond or unsaturation in the fatty acid molecule. So, having said this, these electron deficient centers, these are susceptible to the attack by oxidizing species actually. These oxidizing species are free radicals. For example, RH here in this, we can see RH I have written in this initiation reaction. RH is basically representing a fatty acid of a lipid in a food particle, and where the abstraction of hydrogen atom in the from the fatty acid leads to the formation of free radicals, the alkyl free radical, or we also call it lipid free radical. This lipid free radical gets generated in the initiation step, that is in presence of I, some initiator, and once generated, this lipid free radical can undergo oxygen insertion, triplet oxygen. I would like to explain what is a triplet oxygen at some later stage in my lecture, and the insertion of oxygen takes place and it leads to formation of peroxyl, lipid peroxyl free radical. Now, these two steps accounts for the chain initiation step, because here two radicals, the lipid radical and the lipid peroxyl radical gets generated. Once generated, but this initiation step, we must understand this is not thermodynamically favorable. To make this step thermodynamically favorable, it is the presence of initiator is required. These initiators are high energy species. For example, this can be a free radical, or this can be singlet oxygen. What is singlet oxygen? That would also be dealt with a little while from now. In presence of this reaction takes place, and the generation of this lipid radical and lipid free radical. Now these free radicals once generated can propagate the process to other lipid molecules. For example, this lipid peroxyl radical can react with another lipid and can lead to formation of a lipid hydroxy peroxide and another lipid free radical. So, in this process we can see that one lipid radical, lipid peroxyl radical is being used and one lipid radical is being produced. More importantly is the fact that hydroxy peroxide of lipids is being formed. These hydroxy peroxides are basically the ones which do undergo oxidation in presence of metal ions and can lead to formation of certain volatile compounds which produces off orders. Apart from this, these hydroxy peroxides can also decompose to give alkoxy radical and hydroxyl radicals. These hydroxyl radical is the fastest, can react, is the fastest of the all kinds of radical species. So, this reacts very rapidly and therefore and also is lyophilic in nature and therefore can propagate the process of oxidation and can spread the process of oxidation from one side to the other, and following which alkoxy radical can also abstract hydrogen atom from a lipid molecule and can lead to formation of lipid radical. So, these are the branching steps. So, you can see for one neutral molecule when it undergo decomposition, two free radicals is being generated. So, these are branching processes, and in the chain termination process occurs when two lipid radicals do combine. Well, auto-oxidation, we have seen how auto-oxidation is being brought about. That is, mainly it occurs through an initiation step where the requirement is of an initiator. These initiators are high energy species or very reactive species, the free radicals or singlet oxygen. It does mean there is a difference between types of oxygen, the singlet oxygen or the triplet oxygen. We must understand the atmospheric oxygen, oxygen which is present in the atmosphere is triplet in nature, or basically is the ground state of oxygen. What we mean to say by this is that if we consider the molecular energy level diagram of oxygen, so we find that there are two, in the highest occupied molecular orbitals, there are two molecular orbitals which are degenerate in nature, and the 7th, 8th electron from each of the oxygen atoms which do combine and form oxygen molecule. These electrons do fill up the two degenerate orbital, and these two degenerate orbitals are occupied singly. So, this is the ground state picture of oxygen. This is called triplet oxygen because there are two degenerate molecular orbitals, highest occupied molecular orbitals which are partially filled, that is each orbital has one electron. So, therefore, this is called triplet state, or in other words spin parallel states. Now, coming over to the discussion of singlet state oxygen. Now, when triplet state or ground state oxygen, or in other words the atmospheric oxygen absorbs energy, there can be a promotion of electron from one of the orbitals to that of the other, making a spin paired state. That is, both the electrons now will be occupying one of the two degenerate molecular orbitals in a spin paired state. So, this is how singlet oxygen is being described. So, singlet oxygen is a higher energy species, whereas triplet oxygen is a ground state species. And since a lipid molecule, a fatty acid, all these neutral molecules are in spin paired state, for a reaction to take place, it is important to understand that between two chemical species, it is required that the two chemical species be in the same spin state. That is, if one chemical species in the spin paired state, then the other should also be in spin paired state, then only the reaction will take place. So, therefore, there is no possibility of triplet oxygen as well as and the fatty acids. That is, triplet oxygen cannot abstract proton and cannot bring about radicalization, the chain initiation step. So, therefore, in response to temperature change, that is by virtue of higher temperature, the oxygen can absorb energy and can lead to the singlet state, or in presence of certain metal ions, the activation barrier gets reduced and the singlet state can oxygen can get produced, or exposure to UV light, or physical damage or presence of some photosensitizer molecules, that is in the food. While we prepare food, there are certain photosensitizer molecules also which are being present. So, therefore, all these factors may contribute to the generation of singlet oxygen, and singlet oxygen once generated can only abstract hydrogen atom from the fatty acids, and therefore can bring about lipid can bring about free radicalization of lipids, and therefore can lead to formation of lipid hydroxyperoxides which can decompose and can give you off orders. So, this is how the chemistry goes on in an in a food matrix. That is, food is susceptible to attack by an oxidizing species and can undergo oxidation, can lead to formation of lipid hydroxyperoxides, or can lead to formation, or can also lead or there can also be a result that is degradation of proteins, degradation of carbohydrates, which results in formation of smaller molecules, that is breakdown of substrate molecules, which causes gross change in physical and chemical properties of substrate, mainly the food matrix, and this bring about the degradation of molecules that are present in food matrix and leads to formation of smaller molecules which contribute off orders, flavors, and that is at very low concentration. Even at ppb level of concentrations, if this oxidation process goes on and these small molecules are present, then we will observe there will be off odors and foul smells. We can see over here that there are compounds such as butanoic acid, which due to which there we may observe the rancidity in oils. Propanoic acid, this leads to pungent, rancid or soy kind of smell, and there are so many different kind of compounds, the smaller compounds, which leads to the off odors and aromas. Now, we can see that in the figure there are two different dishes are being, same version of a dish from two different places is been present. You must have seen that we try to avoid taking fried food, for example samosa from the roadside ferry shop, just because sometimes the smell comes out of it. What the smell is due to? This is due to unpleasant smell is due to deterioration and discoloration which gets occurred due to oxidation of oils which are being used in cooking. So, therefore, this is an unhealthy practice of taking food. So, now here comes the antioxidants into play. The use of antioxidants, if they are added to the food matrix, they can prevent the oxidation of food and thus reduce raw material and nutrition loss. As we can see, the lipid molecules which will remain intact, the nutrition value will remain intact, the material, food material, raw material which will be also preserved. Therefore, and this also widens the range of fats present in food matrix. So, no loss and health benefits. So, that is why antioxidants can be made use of as additives to food. Now, these antioxidants we can say are useful in product formulation. Currently, the practice is that in packaged food only there is the addition of antioxidant is being carried out, and these antioxidants are basically the synthetic antioxidants which are synthesized in laboratory, and these ones are butylated hydroxyanisole is one example, then butylated hydroxytoluene is another example, and tertiary butyl hydroquinone, propyl gallate, octyl gallate and dodecyl gallate. These are certain molecules which are being in practice to be used as additives in food matrix in packaged food. Now, the fact of matter is that in place of these synthetic antioxidants, there is a demand and need for naturally occurring antioxidants, because it has been found, for example, neem tree leaves, neem tree bark, or curcumin. Curcumin, which is one of the component which comes from curcuma longa, that is haldi, or there are certain rosemary plant, the tulsi, from which we obtain rosmarinic acid. So, these are the active constituent molecules which are obtained from natural resources, and there has been currently studies are going on and to assess their antioxidant abilities and to basically understand the mechanism of action of these antioxidant molecules, natural antioxidant molecules. So, this is one upcoming research area where, although much research has been done on the extracts of leaves, bark, and their ability to quench the reactive oxygen species, the free radicals, etc., but yet there is a need to understand the mechanism of action, what way the active constituents, what electronic transformations in these active constituents do take place, by virtue of which these naturally occurring molecules can be used as antioxidants in food matrix. So, this is now up to this point we have tried to explain how the antioxidants can be used in the food sector. So, now let us talk about health sector. In health sector, basically to the discussion of health sector, we must start with understanding the fact that all living beings are sustained through metabolic processes. The metabolic processes are very important for sustainability of life processes, living beings. For the sustainability of metabolic processes, it is required that certain level of free radicals or reactive oxygen species be generated, because they are the ones which bring about initiation of digestion processes, cell growth. We will see very shortly what kind of help they are doing in sustaining life processes. So, therefore, it is important that for metabolic processes, generation of free radicals is important, and these free radicals, there are mechanisms in an organism by virtue of which these free radicals gets generated for catalyzing metabolic processes. And for example, in a cell we have xanthine oxidase enzyme, which actually brings about and catalyzes the formation of superoxide free radical. This enzyme catalyzes the production of superoxide free radical by insertion of an electron in molecular oxygen within the cell, and it leads to the production of superoxide free radical. Once the superoxide free radical gets formed, this free radical can further participate in a number of subsequent reaction. In addition, there is nitroxyl free radical also, which can also gets generated in an organism, and these free radicals can lead to can participate in several reactions which lead to formation of subsequent different kinds of free radicals, and these free radicals, they are then become very harmful for the living organisms, although they have their positive roles, but only when their concentrations are limited in a range. But if they go beyond, they become harmful. So, let us see that once superoxide free radical is formed, there is another enzyme called superoxide dismutase. Now, what this enzyme does is that it taps the superoxide free radical anion, which gets formed from the xanthine oxidase enzyme. So, now this enzyme superoxide dismutase now taps this superoxide free radical and converts it to non-radical species by converting first it into hydrogen peroxide and subsequently to water. However, once it leads to formation of hydrogen peroxide in the presence of metal ions, it can bring about dissociation of hydrogen peroxide and can lead to the formation of hydroxyl free radical, which is very reactive in nature and acts very fast on the lipid molecules and can abstract hydrogen atom and can bring about radicalization of the lipids, and lipid free radicals can get generated very fast. On the other way, hydrogen peroxide can also lead to formation of hypochlorous acid, which can further react with hydrogen peroxide and can lead to the formation of singlet oxygen. On the other hand, nitric oxide free radical, there it can participate in oxygen insertion and can form peroxynitrite, and the peroxynitrite then can lead to formation of nitric acid. So, all these are reactive intermediates which gets produced, and actually these are very important. They play a very important role in several biochemical reactions. For example, hydroxylating reactions, carboxylating reactions, peroxidating ribonucleotide reduction. These are many important reactions which are biochemical reactions, and they are very important for sustaining life processes. Apart from this, very important it is to understand that signal transduction, that is transmission of nerve signals, or in other words we can say communication between the cells, that is also a role which is being played by an O free radical, that is very important for our all activities. So, therefore, these free radical species, although when they are produced in excess of certain level which is mandatory, they become harmful. However, they play very positive functions, very important role, and they are very important for sustaining life processes. Now, I just give you one example. There is arginine which gets converted to citrulline. There is an enzyme called nitrogen oxide synthase which converts this oxygen to NO free radical. This NO free radical at femtomolar concentrations, this actually when gets generated in femtomolar concentration is very important, because it transmits nerve excitement transmission, it provides signals to the venous. So, it acts as neurotransmitter. However, when the concentration is greater than nanomolar concentration, then it brings about nitration of proteins, inhibition of enzymes, induction of DNA and lipid damage, and decrease of antioxidant capacity, and increasing of sensitivity against alkylation agents and toxic materials. So, therefore, we can easily see the free radicals or reactive intermediates in the health sector, if in an organism they get generated to a certain level, they are very beneficial and they are in fact indispensable, they are very important for sustaining life processes. On the other hand, if their concentration rises to greater than that of certain levels which are mandatory, then they become very dangerous and very harmful. The way they become dangerous is that they try to attack the important biomolecules in an organism, for example, lipids, proteins and DNA, and they damage these important biomolecules, and we all know that DNA is a storehouse of information and actually guides the growth of an organism. Proteins are very important, and basically every organ there are proteins which is being made up of, and so therefore lipids, that too are very important. These biomolecules, they gets attacked by these free radicals and reactive intermediates greater when they are present in a concentration which is greater than certain mandatory levels, then they bring about damaging of these important chemical species. So, once the damage is done, then body has protection also. It does not mean that body can only generate these, an organism can only generate these free radicals. An organism also has some protection mechanism to counter the excess production of these free radicals. basically there is 3 levels of protection which is being which gets developed in a healthy organism. First level, in which some systems are being present which prevent the formation of free radicals. That is, as I said earlier, xanthine oxidase is an enzyme which catalyzes the production of superoxide free radical. So, therefore, once the active sites is being inhibited by some compounds which gets produced in the body itself, then it will stop the formation of further superoxide free radical. So, therefore, allopurinol is one compound which also gets generated in the body by virtue of some signal. When the body gets the signal that now there is an excess of production of superoxide anion is being done. So, at that time allopurinol comes into action, and active sites is being blocked, and at that time generation of superoxide free radical gets stopped. So, this is one mechanism. There are certain chelating agents also which are present in body itself. When the excess production of free radical occurs, they tap the metal ions. So, as we said earlier, it is the metal ions in presence of which free radical gets formed due to decomposition of hydrogen peroxide. So, therefore, there are chelating agents. So, this is been the primary or the first stage of protection system. When the first stage of protection system, which actually prevents the body from excessive formation of free radicals, when this primary system is insufficient, then our second stage of protection system comes into play. And the second stage of protection system, there are certain important biomolecules which acts as scavengers and tappers of free radicals and convert free radicals into non-radical and non-toxic metabolites. And since these tap the free radicals, so therefore, we would say them as antioxidant, because antioxidant, they were oxidizing our important biomolecules, they prevent the oxidation of important biomolecules by combining with them and with free radicals and turning them into non-toxic metabolites. So, therefore, these are antioxidant molecules. So, now it is important to understand the body itself generates antioxidants by virtue of second protection mechanism from free radicals. So, these are called endogenous antioxidants because they get generated within the body itself. These include, there are two different kind of endogenous antioxidants, one which has very high molecular weight. These are basically the enzymes and proteins, and the ones which are low molecular weight chemical species. So, there is, for example, superoxide dismutase. This is one of the enzyme which actually taps the superoxide free radical, and we can see over here this is the structure of the superoxide dismutase, the active site, where this enzyme taps the superoxide free radical and converts it into water, and here water actually gets this we can see it gets attached, superoxide free radical at the copper 2 site gets attached, and here oxygen gets released. So, therefore, superoxide dismutase has offered electrons to the superoxide free radical and oxygen is being formed, and now there has been a redox change in the superoxide dismutase. Earlier it was present in copper 2 state, now it is present in copper 1. So, it accepts one electron and undergoes reduction, whereas oxidation of this species to oxygen takes place. Now, when another superoxide anion comes in and attaches to copper 1, it once again basically it converts water present nearby to hydrogen peroxide. This oxygen gets transferred from this site to water and can lead to formation of hydrogen peroxide. So, as I said earlier, superoxide dismutase taps the superoxide free radicals and converts them to hydrogen peroxide. So, this is what the mechanism by which superoxide dismutase acts on the free radicals. Then there is another enzyme, glutathione, peroxidase, catalase. All these enzymes have their role, that they act as tappers of free radicals. Apart from these enzymes, there are certain proteins, albumin, transferrin, which actually transports the iron metal ions, and therefore bring down the production of free radicals, and metallothioneins. All these are enzymes and proteins which gets generated in the body itself, and these offer secondary stage of protection from free radicals. And there are certain low molecular weight antioxidant also, you must have heard about these. One is uric acid, lipoic acid, glutathione, and ubiquinol. So all these are the examples of endogenous antioxidants. This is the, for example, this is the crystal structure of albumin, which is being present in the body. Then now when the protection at the secondary stage even also falls, for example, free radical production is in excess, and the endogenous antioxidants also are not being able to tap or being able to control or being able to decrease the concentration of these free radicals inside the body. There is third stage of repair system also, third protection system is also available inside the body, that is, when protection of organism at secondary stage fails, repair system comes to rescue. We know that there are proteinases, lipases, and DNase repair systems. These are enzymes basically which acts on oxidatively modified proteins, oxidatively modified lipids, and oxidatively modified DNA bases, and repairs them. So this is what the three stages of protection system which is being present inside the body of an organism, which prevents from excess production of free radicals in the body itself. So now we must understand, if suppose all the protection system which has been present in the body of an organism fails, what will happen? There has already been an excess production of free radicals. So now there will be an imbalance between the production of free radicals and the protection mechanism which is being present in the body. So therefore this imbalance will lead to a condition where excess production of free radicals is not being countered, and will therefore damage the important biomolecules, the DNA, lipids, and proteins. So in that situation, this damage of these important biomolecules will lead to very varied kind of health conditions. This we will deal with very shortly. So this imbalance is basically termed as oxidative stress, that is, the body of an organism is upon stress from excess production of free radicals, which is not been countered by any kind of protection system available within an organism. So this situation is termed as oxidative stress. Now to counter oxidative stress, we can give to an organism, we can put an organism to a antioxidant therapy, and we must understand what is basically the causes for these production of excess production of free radicals. These are smoking could be one reason, UV radiation exposure could be the other, air pollution at the one hand, auto-oxidation of compounds on the other, and there are many different kind of reasons which could be there for presence of processes which lead to excess formation of free radicals. So oxidative stress which results from uncountered excess production of free radicals can be dealt with antioxidant therapies. That is, we can give an organism doses of antioxidant molecules which can exogenously can be given to an organism, and upon taking these ones, these antioxidants may work on the organism and can lead to the protection of an organism from various diseases. Let us see which are the diseases. There can be a number of diseases, cardiovascular diseases to Alzheimer, diabetic mellitus, and metabolic syndromes, skin and tumor related diseases could also result from this oxidative stress, and of course, physiological process, the aging. So, to counter all this, for example, aging itself, you must have heard about anti-aging drugs. These are nothing but these are antioxidant, basically the antioxidant therapies which has been provided to an organism. So, although many antioxidant therapies have been tried, many clinical trials are also been put to, but yet there is a lot of scope for research in this area. And especially the naturally occurring antioxidant molecules, they are being the focus of enormous research interest from the researchers community, because we all know we have been having an exposure of these naturally occurring compounds through extracts of natural plants, for example, neem tree extract, for example, haldi, the turmeric, we have all been exposed to. So, therefore, there are active constituents which are present in these naturally occurring herbs, where we can extract from them and we can understand what way they are actually playing their role in curbing various diseases through an antioxidant. It could also be an antioxidant mechanism. So, the research area which is open nowadays, it is not that we all know that there are different kind of herbs which are present, and the extracts of this through ethnopharmacy, we all know that they help us in countering this disease or that disease. But now it is time to understand what way they are actually, what are the active constituents. This is also known nowadays, and next step is important to research is that what way these active constituents which are present in naturally occurring, which are present as naturally occurring compounds, what way they act on a particular mechanism within a body and can lead to our rescue from various diseases, maybe through an antioxidant mechanism. So, we have come to know that in health sector there is an issues of oxidative stress which lead to many diseases, and this need to be countered with the application of, with the introduction of exogenous antioxidants. So, now in the health sector, these antioxidants can be further classified as primary or chain breaking antioxidants or secondary or preventive antioxidants. Let us see what these are. Primary antioxidants basically act as free radical scavengers, the way the endogenous antioxidants acts, or they also delay or inhibit the initiation step so that the production of free radicals can be stopped. They also interrupt the propagation step of auto-oxidation. That is very important. That is why they are being called chain breaking. So, because the propagation step needs to be curbed, so that once the free radicals are being formed into certain level of concentration, the branching should not occur. So, they stop propagation step of auto-oxidation also. So, that is why they are called primary or chain breaking antioxidants. And it is important to note that primary antioxidants cannot inhibit photosensitized oxidants. For example, singlet oxygen they can't do away with. However, free radicals then they can tap. On the other hand, there are secondary antioxidants, secondary or preventive antioxidants. These offer their antioxidant activity by slowing down the rate of oxidation reaction. These also acts as chelators for pro-oxidant metal ions, and of course, deactivating singlet oxygen as an oxygen scavenger they also act. So, let us now understand the mechanism of action. Suppose AH is an antioxidant molecule where there is an abstractable hydrogen atoms which are present in an antioxidant. These are usually the phenolic hydroxyl groups. So, from an antioxidant molecule which when react with, for example, a peroxyl free radical do form hydroxy peroxides, and also leads to formation of antioxidant free radicals. These antioxidant free radicals does not have affinity towards important biomolecules, have very low reactivity towards biomolecules such as lipids, proteins and DNA. Moreover, they can also lead to the formation of restoration of lipids they can give electrons and they can also give hydrogen atoms to these lipid radicals, and can that way they can restore the lipids, and also they can form antioxidant peroxides, that is a lipid peroxide free radicals. When they combine with antioxidant radical, they form lipid antioxidant peroxide. And similarly, we can understand that antioxidant molecule, they can react with free radicals and can lead to production of neutral species, or there can also be that antioxidant radicals which gets generated, they can combine to neutral dimer of antioxidants. So, therefore, this way antioxidant comes to rescue important biomolecules such as lipids, proteins and DNA. Now, which antioxidants we are talking about? Is it important to note? Naturally occurring antioxidants. There are 3 classes of naturally occurring antioxidant compounds which are currently is the focus of important research nowadays. These belong to the category of flavonoids, the curcuminoids and rosmarinic acid. What these flavonoids are? Flavonoids basically has flavin structure where 3 rings are present. One, this A ring, and there is a B ring and C ring. It is being known that it is B ring and the C ring which plays a very vital role in offering antioxidant activities through these phenolic groups, where the hydrogen atoms can be abstracted from the free radical by the free radicals and can lead to the formation of antioxidant radicals. This quercetin, for example, is a very important constituent of neem tree leaves extract, bark extract, or is also present in various fruits which are colored fruits, for example berries and so many other fruits. This is an active constituent. Curcuminoids, for example curcumin, I have shown the 2 equivalent forms of curcumin, one is keto and one is enol form. This curcumin is basically the constituent, this is one of the curcuminoid, is a compound of curcuminoid family and basically comes from Curcuma longa, which is just nothing but turmeric we all have in our homes. So, this molecule is present in turmeric powder which we usually use in our household every single day. Now, rosmarinic acid RMA, this molecule you can see easily, this molecule is basically comes from rosemary herb. What is rosemary herb? We also have this herb in each home. This is tulsa, or we also know it as tulsi ji. Basically, this rosmarinic acid also has a very important antioxidant potential. Now, it is important to understand that, as I have said, that phenolic hydroxyls are very important for offering antioxidant activities, but we can see in all these structures there are very many different hydroxyl groups which are present, phenolic hydroxyl groups which are present at different sites. Now, it is important to understand that which site, which hydroxyl group, which structure, what are the essential conditions within a structure of a molecule which is important to offer antioxidant activity. This is where the new area of research is coming up, and lot of research is currently going on. For example, there is a theoretical research also. What is theoretical research? We can suppose, for example, one stage of research is that we can form an extract of some plant leaf, its bark or so, and can make an assay of free radicals and can see after a certain period of time when the application of extract is being carried out, how in the assay, how much is the concentration of free radicals which is being tapped. So, that is one way, that is the experimental study. There are a lot of things have been done at this level. Now, next level is isolation of the active constituents from naturally occurring plant extracts, and then using these ones to understand their potential, to what extent they can scavenge the free radicals. Now, next level is the very important level of research, which is the focus of enormous interest nowadays. the structure property relationship. What structure of a molecule we require so that we can have desired properties, for example, antioxidant properties. This is called structure property relationship. So, therefore, a complete knowledge of structure property relationship is very important to understand antioxidant potential of any active constituent, any molecule. So, quantum chemistry can come and can offer help in this direction. In quantum chemistry, you must have read that there is a Schrodinger equation in 12th standard chapter of atomic structure. You have seen that we have a wave function upon which an operator applies, and this operator when operates upon wave function give us the energy and the wave function back. So, we can determine the energy of a microscopic system. For example, hydrogen atom which can be solved for and its energy can be computed, because hydrogen atom is one electron system, one particle system. So, therefore, we can solve it. However, we cannot solve precisely and completely any other molecule or any other microscopic system which is more than one particle. So, therefore, there are approximate methods which are available for solution of those microscopic systems, and we can find using the quantum mechanics the energy of any system, any microscopic system, for example, any molecule, any atom or so. So, we can also subject this science, these antioxidant molecules to this science, and we can find the energy of the molecules by approximate methods. And we can also calculate the energy of the excited states when we eject one electron or we supply one electron to these antioxidant molecules. In that situation, this will be antioxidant cation or antioxidant anion. The difference of energy between neutral species and the cation and neutral species and the anion will actually be nothing but the ionization energy and electron gain enthalpy. So, therefore, these are the usual concepts you must have read in 11th 12th standard chemistry textbooks. A lot many times these are being discussed. Now, see how we can make use of these calculations. Calculations of energy of system can lead to calculation of electron affinity and the ionization energy, and which can be used to calculate the electronic chemical potential or electronic Gibbs free energy, and we can calculate from a molecule how much is the Gibbs free energy change will take place for a particular supply of electron to reactive species. So, we can, by virtue of this calculation, wherever we find for a molecule there is greatest of Gibbs free energy change, greatest negative Gibbs free energy change, this will be the most feasible of the reactions. And we can also further calculate within a molecule at different atoms the charge density before the electron ejection and after the electron is being ejected and is being transferred to the free radical molecule. So, therefore, this way we can calculate at which are the sites where from where there has been greatest transfer of electron density has been taken place. So, so antioxidant activity is being offered through electron ability to transfer electrons, and from where there is greatest charge, greatest electronic charge is being transferred, that will actually be the site of antioxidant activity. So, further experimental evidence can be collected. You will understand in your undergraduate chemistry courses the spectroscopic techniques and other techniques which are very helpful. So, you must understand whatever you are trying to read. They are not abstract topics, but have very important utility in research. So, this is one such area of research I have exposed in and is the antioxidant chemistry. So, on this note, I thank you very much for your patience listening. Thank you.
With this note, in fact, we should say thank you to you, sir, for giving us deep insight into the topic that is antioxidant chemistry, that the area on which the research could be done, and if you are thinking about doing research, so it is the most appropriate, one of the most appropriate areas, I would say. Dear friends, if you have any queries, you can mail us at info.cec@nic.in. We would love to solve your queries next time when Dr. Amit Kumar visits our studio. And dear friends, if you want to access this particular lecture, you can access it with the help of YouTube, the number of times, the ample of times, and I hope that this particular lecture will help you in widening your knowledge. Thank you, sir. Thank you so very much for being the part of the EduSet lecture, and in future sessions also we would be discussing on our ongoing series as well as some more of the other major areas on which the research as well as the great work could be done. Thank you so very much.